Hello my dear students, this is Dr. 𝗲𝗵𝗿𝗺, your biochemistry faculty. Well, in this video we are going to discuss again a very important and an interesting topic. It is from nutritional biochemistry and the topic is respiratory quotient. Because whatever we eat, what happens to when we are having carbohydrates, because nowadays if we talk about the dietary pattern, it is being changed. Some people are opting for keto diets, some are opting for protein diets, there's so many diets which are coming up nowadays. Okay, so basically what happens when we are taking carbohydrates, what happens when we are taking fats, because again if I talk about different stages in the body, we know that our body is having a well-fed state. Right, when we are having either a carbohydrate-rich meal or a fatty-rich meal or a protein-rich meal. After well-fed starts the fasting one. So this fasting can be early fasting, because if we are having a breakfast say around 8 or 9 o'clock and we are giving some 4-5 hours break and then we are having our lunch. So that stage is that our body is going into fasting. So whatever is there, it will undergo post-absorption, it will be absorbed, it will be assimilated to give energy to the body. So fasting can be early fasting, it can be late fasting also. Right? Now, and it can be delayed fasting also. Just after having dinner, when we sleep. So, it's like our heart and brain are still active during the night. So, what is the source of energy when we are sleeping? Because we are not eating anything. So, that time the glucose which is stored in the form of glycogen will undergo breakdown to give energy to the body. That is why whenever we have to estimate glucose in the serum, it is always the fasting sample, and that too it has to be collected after 10 to 12 hours of fasting. Okay, so these are very, very important, which actually are very useful in diagnosis of so many important diseases. And if we talk about prolonged fasting, which means starvation, it is known as starvation. Then also our body is intact. And prolonged starvation is like, so there is a time period for everything. So if we are not eating for 2-3 days, then the body undergoes prolonged starvation. So it will be after 3 to 4 days. Right. So if we talk about the well-fed state, we can say that all the anabolic processes occur. We know that this we have already discussed in the videos. And if we talk about fasting, the catabolic processes are the ones which are accelerated. Same is the case here, same is the case here. Okay, so basically what is this respiratory quotient all about? Quotient is a ratio. And respiratory means because there is a difference between digestion and respiration. We are eating something, whenever it is broken down, it is going to release energy. So the pattern is like that. Initially, whenever the body is undergoing fasting, glycogenolysis is the one which is giving energy to the body. After glycogenolysis comes gluconeogenesis. After this comes fatty acid breakdown or beta oxidation. Right? And then comes ketone bodies into picture. And last but not the least, I would say the substrates which can give energy to the body in the end also, protein breakdown or proteolysis. That is why we say after 4-5 days the body undergoes cachexia. Okay, so and that is why even if we keep the body for a longer time, whenever there is putrefaction, the bad smell, the foul smell of these proteins comes. So this is the pattern. So you can say it's like 10 to 12 hours, then it will be say 14 to say 20 hours, like that it keeps on changing. Fatty acid breakdown will take place after gluconeogenesis, which will lead to the production of acetyl coenzyme A, which will be diverted to form ketone bodies. Okay, because ketone bodies are the preferred fuel of energy during starvation to heart and brain. Because our heart and brain are the only two organs which just cannot stay without energy for even a parsec of a second. And if we talk about the distribution of the organs, this is very clear that there are 3 stages: fed, fast and starvation. Okay. So, if we talk about the fed state, or if we talk about heart, brain and RBCs. RBCs ka it's like by default they will always require glucose for energy. Be it the fed state, be it the fasting state, be it the starvation. Coming over to brain, brain will require glucose for the during fed state, glucose during fasting, and starvation mein it will go on ketone bodies. And when we come over to heart, heart mein instead of glucose it will be fatty acids. In the fed state, fatty acid in the fasting state, but during starvation they will depend on ketone bodies. Time and duration I am not mentioning here because this we have already discussed in detail in our previous videos. So now the question here is, what is this respiratory quotient? Commonly we call it as RQ. The abbreviated version is RQ, and this is volume of or amount of carbon dioxide given, released over volume of oxygen consumed. Very, very important. So, we can define respiratory quotient as the amount of carbon dioxide released or carbon dioxide produced to the volume or amount of oxygen consumed. So, first of all, if we talk about the RQ of carbohydrates, carbs, we can say that simple 𝗲𝗵𝗵𝗺 plus 6 oxygen, it will give 6 carbon dioxide. I am just mentioning over the main ones, and it will give water also. Okay, so if we calculate the RQ of carbohydrates, it is 6 over 6, which comes out to be 1. So, respiratory quotient of carbohydrates is 1. Very, very important. Similarly, if we talk about the RQ of fats, because in our body mainly palmitic acid is there. So, if we talk about the RQ of fats, or if I take about palmitic acid, it is 0.7. Okay. If we talk about RQ of proteins, always remember these proteins are a very, very important sources of energy, in a sense that they have maximum specific dynamic action, having maximum SDA. And if we talk about their RQ of proteins is roughly 0.8. If we talk about the mixed diet RQ is 0.85. Okay, so we can say that fatty acid has 0.7, proteins have 0.8, mixed diet is 0.85, and the RQ of carbohydrates is 1. Now, the question is, what is the clinical implication of this RQ or the respiratory quotient? So, always remember, whenever we talk about the clinical significance is that during starvation or diabetes mellitus, there will be always a drop in RQ. But on the administration of insulin, whenever a shot of insulin is given, it is going to increase RQ, because again we have to just absorb, we have to degrade, we have to assimilate the carbohydrate, because in diabetes and starvation, the condition of the body is the same. Starvation mein, when we are not having anything from outside diet, and diabetes mellitus mein, everything is there but the tissues cannot get the energy. So what happens there during starvation? This is very, very important. And diabetes mellitus, people have generally low RQ, right? But on administration of insulin, it increases. It will increase, and this is a very important aspect, right? And if we talk about ketone bodies and all, if we talk about the RQ of ketone bodies, it is 0.7 during again ketone bodies utilization or during starvation, right? This is again very, very important aspect of RQ, that it will be 0.7, because again during starvation there will be utilization of ketone bodies. And if we talk about the lipogenesis, it is like this. Why? Because in lipogenesis, the consumption of oxygen becomes, so carbon dioxide becomes more than oxygen. The production of carbon dioxide is more than oxygen, right? And whenever you can say respiratory quotient plays a very, very important role again in the hospitals also. Whenever a person is on ventilator, we have to give the diet as per the respiratory quotient. If he is undergoing starvation, if he is chronic diabetic, so we have to keep these parameters in mind. Okay, so this is what is the significance of respiratory quotient. And if we talk about the definition here, this is simply the volume of carbon dioxide, we can call it as amount also, over amount of oxygen consumed. Okay, and this also we have to understand that if we talk about the fed state or the fasting stage or during starvation, RBCs will always depend on glucose, brain will always depend on ketone bodies during starvation, and heart will also depend on ketone bodies during starvation. Because again RBCs, that is why we always say in diabetes mellitus the worst effect is on the blood, and that is why the whole organs are like destroyed in a sense, because blood is the one which is taking the nutrients from head to toe. Okay, so this is a respiratory quotient which plays a very, very important role in nutritional biochemistry. Here I have not mentioned about the time period also, but yes, the most important point which you have to remember is the first method, the first process, the first, I would say, substrate which is giving energy to the body is glycogenolysis. Then gluconeogenesis comes into picture. Then fatty acid breakdown, which is beta oxidation of fatty acids, come into picture. Then ketone bodies, and then there is breakdown of proteins. So this is how the body is divided into well-fed, fasting and starvation, and this is the respiratory quotient, right? And you just have to remember one thing in this: what is the RQ of carbohydrates, what is the RQ of fats, of proteins, of mixed diet, and what happens in starvation and DM. That's it. Okay. So this is all about the significance of respiratory quotient and what is this respiratory quotient. I hope you have understood, because this small topic carries a lot of weightage in the field of medicine. So this topic you have to understand clearly, because nutritional biochemistry is such a topic which is actually very helpful in fact almost planning of the diets also. So this is a very important topic, and that's all about this. Thank you so much.